In order to be able to get an answer when you're solving a system, if you're going to get a number answer, you have to have at least as many equations as you do variables. In other words, all these problems with 2 variables, I was giving you 2 equations. Whether they were linear or not, if we had an x and a y, I had to give you 2 different equations in order for us to be able to get an answer. When I'm looking at systems with 3 variables then, we will have to have 3 equations if we're going to get an actual number answer. So let's take a look at one. I want to solve this system of equations. So if I am trying to solve this, if I want to get a solution, we're actually only going to take 2 equations at a time. So let's say I pick the first 2. I'm going to take those 2 equations and I want to eliminate a variable. So which one do you want to eliminate?
X.
X. Okay, what would I have to do to eliminate x?
Times it by -4.
Okay, so I'm going to take the top equation times -4. And the second equation stays. So we're going to add those equations together. My x's cancel, so I have -7y plus 6z equals 20. Now, I need to take the equation that we have not yet used. So that's this third equation. I am going to put it with one of the other 2, and I have to eliminate the same variable. So I need to eliminate x again. Which equation do you want to pair it with?
The first one.
Okay, so if I take the first and the third, if we want to eliminate the x, we have to take the top one times -2. So if I add those together, my x's cancel. How is this helpful?
Can we add those together?
Yeah. Now I have 2 equations with 2 variables, so we can put those 2 together and eliminate something. What would be easiest to eliminate?
C.
C. So if I took this one times 6, then my first equation stayed. This gave me a -24y minus 6z equals 42. So when I add these together, divide, we get y equals -2. So now I have my y. We have to work backwards to get our other variables. As soon as you have one, it's going to become a lot easier to get the others. It's just working backwards. So I'm going to take y and plug it back into one of those. So maybe if I put it into this one, I have -4 times -2 minus z equals 7. Z equals -1. So now I know z is 1. So I have y and I have z. How do I get my x? Yeah, plug both of those back into one of the three original ones. If I just did the first one, we have x plus y, which was -2, minus z, which was 1. So x minus 3 equals -1, and x is 2. You should always be able to check these. It should make all three equations true. Now if we check the first one, it works. We do this one, we get 8 plus 6, which is 14, plus 2 is 16. 4 plus 4 is 8, minus 3 is 5, so it works. When you write these, you always just put them in alphabetical order. So in this case, it'll be x, y, z. So x was 2, y is -2, and z is 1. So it adds a lot of work by adding that one more variable. There are other strategies, different ways of doing this when you have more than 3 variables, because those become so complicated. We aren't going to have time to get into that this year, so this will be the most variables I will give you, is the 3 variables. All right. Is that one okay? Let's do this one. What do you notice about this one?
No Z on the third one.
There's no z in the third one. So if I want to save myself time, since this one doesn't have a z, I would probably eliminate the z in the first and the second. So if I just pair those together, it's already set up to eliminate the z. So if I put those together, we get 3x plus 2y equals 3. So now I have not used the third equation yet, so I have to use it. Since it only has x and y, I can pair it with my other equation that only has x and y. So if I wanted to eliminate x, what would we have to do?
-1.
I have those together. My x's cancel and my y's cancel. So we get 0 equals 3.
No solution.
Right. Remember on those we say no solution, and I also want you to write inconsistent. Sound okay? Let's do a word problem. So that's what we were doing Friday. And we know really this is no different, but we're going to have to set up our system by defining our variables and writing the equations that go with each. So an investment of $35,000 was made by a business club. The investment was split into 3 parts and lasted for 1 year. The first part earned 8%, the second part earned 6%, and the third 9%. All right, let's stop right here. What am I trying to find?
The amounts of 3 parts invested.
So x would be the amount of the first, y the amount of the second, z the amount of the third. All right, so if we have 35,000 altogether, what's my first equation?
X plus Y plus Z equals 35,000.
Then we get into our interest. So the first part earned 8% interest.
Homework calculator.
So what would we have to write? The second one was 6%.
0.0.
And the third one was 9%. And that equals my total interest, which was,
2,610.
okay, so we have two equations. The third, the interest from the first investment. Okay, my first investment is X. The interest from that is my 0.08X. Was, which is like saying equals, 2 times the interest from the second. So what would be my interest from the second one?
0.06.
0.06y. All right. So I've defined my variables. I have my 3 equations. How do you want to solve this?
Get rid of the Z's.
Okay. So if we did that, eliminated the z's in the first and second, and that's not the only way, what would I have to multiply the first one by? What's 35,000 times negative 0.09?
Negative 3,150.
Okay. And then we're keeping the second one for a minute. If I add those together, we get negative 0.01x minus 0.03y equals negative. Okay. What am I going to do with that?
Take it times the bottom one, or the third one.
Okay, so we have 2 options here. We can either do substitution or elimination with these 2. We have to use these 2 equations, right? It might be easiest on this one. We have 0.08x equals 0.12y. So if you wanted to solve for x, if you divide by 0.08, you get what? 0.12 divided by 0.08?
Where did you get that?
15.
Mm,
Did she do? Oh, 0.12.
I multiplied the 2 times the 0.12. So we get 3/2 y.
Mm-hmm.
So then we could substitute that into the first one. So we have negative 0.01 times x, which is 3/2 y, minus 0.03y equals negative 540. Well, this isn't the only way, but it'll work.
Is that 5.40?
No. I started to mess up. Just So when I do that, I get my y to be 12,000. We have to find everything, so if you go back and plug that in to get x, we get x to be 18,000. And so then we have to plug those back into the original. So that's x, which is 18,000, plus y, which is 12,000, plus z equals 35,000. And we get z to be 5,000. How do we have to finish it?
X, Y, Z.
And actually, since it was a word problem, let's write it in a sentence. So there is 18,000 in the first. $12,000 in the second. And 5,000 in the third. So when I look at this problem, I know from the beginning that I'm not going to be able to just get a number answer here because I have 3 variables but only 2 equations. So we aren't going to get an actual answer, a number answer. This will be like the problems where we had infinite solutions and we had to write one of the variables arbitrarily. This tells me that we are going to do it in terms of x. So in my answer, we have x, y, z. X is still going to be x, but we have to figure out what to plug in for y and for z. How could I easily find my y?
Times it by 2. Or no, get it by itself.
Yeah, in that second equation, couldn't we just get y by itself? So y would be 4 minus 2x. So there's my y. All that's left is to get z. So what I'm going to do is substitute this into the first equation. So we have x minus 2. My y is 4 minus 2x. So distribute my negative 2. So we get 5x minus 8 plus 3z equals 7. I'm trying to solve for my z. So if I add over my 8, subtract over that 5x, and then my final step would just be to divide by 3. So we get 15 minus 5x divided by 3. Or you could write that as 5 minus 5/36. Those are equivalent, so either one is fine. So if I give you more variables than equations, your answer is going to look something like this. So this is the whole section. There is a math Excel assignment. It has 7 questions. That is the assignment for today and tomorrow. So tomorrow I might do 1 or 2 examples when we come in, just kind of refresh and talk about strategies again, but you will have a good portion of the class tomorrow to work on it. And then you do have time